Second normal form that we discussed, huh? Huh? Completed, huh? Okay. Up to second normal. Only definition is completed, right? The fully dependency. Yes or no? Okay. So once again, you can come back and second normal form. Okay. So what it was a second normal form? Just your table should be satisfied the first normal form techniques, conditions, whatever it was there. And as well as in your table, there should be no partial dependency columns. And we discussed on Saturday what is fully dependency. Fully dependency means what now? All non-key columns. That means non-primary key columns are depends on a key column. That means your remaining complete data or complete information is depends on a particular column, and that column should be primary key. So when that kind of situation has come to you, then the table is called as a fully dependency columns table. Okay. So like we said, the student ID is a primary key and name, branch, address. These are non-primary keys. So when it was depends on this all information on student. It depends means what now? With the help of which column I can get your entire the details. So that kind of situation called as a dependencies we call. So if I want to ask here one thing, suppose in this example only, can you carefully observe if I'm going to asking now. So if I wanted, okay, a particular student, okay, details I wanted, but the student details, if I want to take with the name wise, what it was happening, you can see, we are writing like this, select star from E, okay, star from student or student details. So where the name is equals to if I was given Sai. So when I was given Sai, what it was happen? Year 2, for example, in your table, how many people names are matching Sai? That all people are come to us. But I don't want it all people. I wanted a specific person. So this is not possible to get a specific. Suppose another example is there. If I'm going to getting that, select a star from student details. Okay, where suppose I want to use branch is equals to CSC, I'm giving now. If I want to use my branch column, okay, as a conditional column, if I use but still I'm not get specific required row. Because when I'm passing CSC means here, how many CSC people? 3, all CSC people will come to you. So that is also not going to be happen to get our required data. If I want to use another one is called as what now? Select star from student details, where what is this? Address, where address is equals to, suppose I was given HYD. So if I want to give it based on address column also, if I try to get my required information, but still there also we are not getting. So I wanted a specific student information means except student ID column, if any column you can use, what it was happen, we are not getting accurate results. If you have a duplicates are coming to us. But to overcome this problem, I wanted exactly what I'm expecting. Okay, that person I wanted. Who is this I wanted here? Sai, CSC. Okay, this student I want it now. So the student, if I try this, both are coming. Try this, 3 people coming. Try this. Okay, 2 people coming. So that's what I want to do now. Now I want to write like instead of going to be user. Okay, instead of going to be use student details, where student ID is equals to 101. Tell me who will come? exactly who you want it. So 101 student ID, which Sai you want to expected, that person only I can, but this person will not come. So this is called as a dependencies we call. That means your name, your branch, your address, your remaining all details are I can fetch with the help of student ID column. So this kind of situations we called as what no fully dependency columns we called. So that means there is no partially dependency column in this table. So that's why what we said, we don't want to do any modifications on this table. I just carry forward. Okay, na? But when come to partially dependency, what is the mean by partial? Partial means off. Remaining things are not supported. Okay. So partial dependency means what now? In a table, if non-key column, non-key means non-primary key column, depends on the part of key column, depends on the part of key column. Part of key column means any one of the column. Then it is called as a partially dependency. For example, you can see here, example, definition example, A, B, C, D. Okay. Here A comma B is called as what now? Primary key columns we called. A comma B is called as what? Primary key. So can I apply primary key on multiple columns? Yes, sir? Yes. So the type of primary keys are called as what? Composite primary keys. Okay, on Saturday I said to you, normalizations, if you want to understand, you have a good idea on primary key, foreign key, composite primary key. If these three definitions you know, mechanisms you know, normalizations are very easy. Okay. So, okay, fine. So A comma B on this two, I was applied what now? Primary key constant. Then whenever you want to apply primary key on multiple columns, the type of primary keys are called as a composite primary keys. Understand now? So now AB is a key columns. C comma D are non-key columns. Then D depends on B, but not A, is called as a partially dependency. C depends on B, but not A, is called a partially dependency. Suppose C depends on A, but not B, it's called a partially dependency. D depends on A, but not B, is called a partially dependency. That I said. Some children are having both parents, mother and father. When the children depends on both of them, it's called a fully dependency. When a children was depend on only one person, okay, either mother or father, it's called a partially dependencies. So here also, D depends on B, but not A. D depends on A, but not B. Like C depends on A, but not B. C depends on B, but not A. Anything is going to be happen in this. Okay, na? Then we called as that column is called a partially dependency column. Understand, na? Let me see some example on this. Here, carefully observe. I have a score table here. The score table, student ID, subject ID, this both of them, okay, composite primary keys. Marks and teacher, these are non-primary keys. Now let me see. Marks is also non-primary key. First, a marks column, check it out. Marks column depends on student ID na, subject ID na, or both of them are. Marks, both of them are. So student is required, subject also required. Then they will called as getting marks. So marks column is a depends on both of them. That means marks column is a dependency, partially dependency or fully dependency. Fully dependency, because it was both column dependent. But whereas come to teacher column is there. So teacher column is depends on students subject, not a student. Why? Because suppose you guys are there. After 10-15 days, your batch is completed. So you people will be leave. So you people leave, and in your place, one more new batch will come. New students are come. Okay, but I'm teaching what now? Oracle. So my subject is permanent. Teachers subject is permanent for teacher, but students are temporary. So you're just coming and leaving. Once your course is completed, you left from the Naresh IT. Yes or no? You are not permanently stick with Naresh IT now. Even though your colleges also, how many years you will be spent in the college? Your academic, 4 years, 3 years, 2 years. Once your 4-year BTech is completed, you left from your college. So you are not a permanent, you are a temporary people. So here teacher is not depends on students because students are not permanent. It's a temporary for teacher. Yes or no? But which one is permanent for teacher? Subject. Teacher is always depends on what? Subject, not students. So that means teacher column, a non-primary key column, depends on subject, but not a student. That means, is it partially or fully now? It's a clearly identification is what now? Partial. So now I have a partially dependency column in this table. But as per second normalization, what it was say? Partially dependency columns should be there in table or should not be there in the table. Should not be there in the table. So then what I want to do, if this column is not removed from this, okay, from this table, then this column is not satisfied second normalization technique. Understand na? So if this table want to satisfy your second normalization technique, then mustn't be the teacher column should be separate. That means remove from this table. Okay, then only your second normalization satisfied. Okay, now we can see what I'm going to do. So teacher is a partially dependency column, and which is partially. So in this table, for our easy understanding purpose, I'm taking one column. But if you go to real time, suppose your table is having 100 columns. In 100 columns, how many partially dependency columns are there? That all we need to find out. After finding, suppose 100 columns, there are 20 columns came as partially dependency columns. Then those 20 columns will be separated. That be separated means what now? We'll make another table. We'll make another table. These 20 columns I'm removing from this table. And based on this 20 table, I'm creating new table. Remove means I'm not remove that columns. That columns I should keep it here. But I'm keeping in separate table. Understand na? Same thing here also we did. Now we can see here subject one new table I'm creating, and below score, this is score table, this is subject table. In subject table, teacher column I kept, and subject ID, subject name, and teacher. So in this table, subject ID, if it is a primary key constant, okay, I'm keeping here, it is a primary. So primary key constant means subject name, teacher, non-primary keys. Now tell me, subject ID based on subject ID, can I get the remaining information about teacher? Yes or no? So that means here in this table, do you have any partially dependency column or all are fully dependency? All are fully dependency because of reason subject ID. Subject ID is a primary key. Based on subject ID, the remaining columns data I can fetch. That's why I'm saying that subject ID, employee ID, PAN card number, Aadhaar card number, these are all are what? Key columns. Based on your PAN card number, I can get your entire details. Based on your Aadhaar number, I can get your entire details. Okay, based on employee ID number, employee entire information I will get. So on which is our key column? On the key column, remaining all data will be depends on that. The type of situation is called a fully dependency. Now it is a fully dependency now. Yes or no? Yes, fully dependency columns only, no partially dependency. And here also come, here also fully dependency, no? Yes or no? Yes, marks column. Both of them depends, na? So here also fully dependence. So now what happened? These two tables are satisfied second normalization form. There is a no partially dependency columns in these two tables. So now these are carry forward into next level. And the next level is what? Third normalization form. Understand, na? Third. So that means a simple, guys. When database projects, when they develop here, whatever the client requirements we are taking, based on the client requirements analysis, they will be go to preparing one final documentation. After that, the project leads, what they will do, as per this client requirements, the final requirements, whatever it was finalized here, that's called a final documentation. Based on the final documentation information, how many tables this project is required. Okay, na? For example, as per client project, client requirement, after finalizing your requirements, then they will analyze here, this project is required 50 tables. Understand, na? Okay, the 50 tables they want to first design. In this designing of 50 tables, okay, they will be checking. Okay, first normalization checking. Whatever the conditions are there, each and every table is satisfied first normal or not. Next, they will check second normalization technique. Second normalization technique is what now? Every table is having fully dependency, na partially dependency columns are there or not there, checking. If, for example, 50 tables, there are 30 tables are fully dependency columns are there. Then those 30 tables, I don't want to disturb, because those 30 tables already satisfied my second normalization form. Then remaining 20 tables are having partially dependency columns in each table. And those partially dependency columns are taking from each table, keeping into separated tables. This is what the technique of normalization. So that means, for example, if you want to understand, this is one table was given by client. Client, what he was saying that in this, oh, there are so many columns are there. It's a very big data. Lakhs of records are there. But this table is called as a denormalization table. So denormalization, yesterday I explained, na? Denormalization means what now? The different types of data we are storing into one single table. Like I was given explanation. What is that? Branch and student. Branch and students, two different data. This two different data, when you combine together and keep into one single table, what kind of problems we faced? Data redundancy, memory wasted, data inconsistency, insert, update, delete. These are the problems we faced here. So suppose the one client was given, one denormalized table was given to us. This is a denormalizer. So different types of data having in the one single table. So then denormalized table, when there was given to us, okay, then company, that means developers, that means your database people, what they will do? First, it will be checking first normalization technique. First normalization technique is satisfied or not, first they will check. Okay, okay, sir. First normalization successfully satisfied. Okay, next, what I need to check on this table? What I want to check on this table? Second normalization, I want to check on this table. So second normalization, as per the conditions, what now? Your table should be satisfied in first normal form, and your table should not contain partially dependency. So first normal form already satisfied. Then what I want to check? Partially dependency columns. Suppose in this table, there are few columns, I find out partially dependency. So those partially dependency columns are what I am doing here, separated. those partially dependency columns are separated. Understand now? After separation, then how many tables it will be formed? How many tables form? 2 tables will be formed because one is existing table and whatever you separated, the separated table. Yes or no? So existing table is 1. Okay, now, and separated whatever the columns you separated here, those separated columns table is 1. So that means 1 table data after second normalization technique was implemented, then how many tables it was split? 2 tables split. After splitting these 2 tables, okay, again what I want to do, first normalization checking, satisfied. Second normalization also satisfied. Then what next? I want to check my third normalization technique. As per third normalization technique, I am applying on these tables. Third normalization technique, what it was say, your table should be in the second normalization form, first of all. Second one is, in your table, there is no transitive dependency columns. So now this is already second normalized, already satisfied. Now directly I'm applying what now? Third normalization, second condition. What is the second condition? No transitive dependency columns. I'm checking here. In this table, is there any transitive dependencies are there or not there? Suppose there, then what happened? Again, separate. Again, 2 tables are forming. Again, 2 tables are forming. Okay. Next, this table also I'm checking now. Here also have. Again, here splitting into how many tables again? Again, 2 tables. Suppose I'm telling if it is have, you can. Otherwise, no need. Okay. Then after checking of this, again, these tables I want to check again. First normal, satisfied or not satisfied. All tables are satisfied, first normal. Then again, I want to check what? Second normalization. Second normalization checking or not. Suppose second normalization, all tables are satisfied, nothing problem. Then third normalization, okay, satisfied. Then what next I have to check? BCNF. In BCNF, each and every table I want to apply. So BCNF, what it was say, first your table should be in the third normalization form. After super key columns are, we need to find out. Suppose in this table, I find out super key columns. As per super key column, this table is going to be splitting into 3 tables. Splitting into 3 tables as per super key concept. So 3 tables. Now in this table, there is nothing problem. I keep it that. Next in this table, have a super key columns. Again, I have to split into that. Again, I have to give it a super key columns are there here. Again, I have to split into that. Okay. Again, I check. So next BCNF is there. If you want to check a 4NF, 5NF. So these are the optional. Checking or not checking later. But see here how many tables form? Client was given one denormalization form. So after denormalization form, we'll be designing into how many tables? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So that means finally in this project, how many tables will be formed? 13 tables are formed in this project. This is the concept of a normalization. Understand? Na? So, but this normalizations in which level checking? Designing level checking. If you're checking into implementation level, after table is created, entire facilities are applied, then later I found partially dependency. What's happened? That entire table I want to destroy it again. Again, destroyed or not? Yes. That's why development level, normalizations will never check. Which level? Designing level, each and every content will be checked. After finalizing, then that will be sending to developers. Then developers will be original database will develop. So this is actually normalizations in real time, how the people will be using. Understand na? So concept clear na? Same pattern. Now what I want to check now? Third normalization I want to check. Third normalization, you can see for a table to be in the third normal form, how can you say my table is in the third normal form? Means again, there is two conditions. One is it should be in the second normal form and should not have transitive dependencies. Okay, na? So your new technique, what is the new technique? Transitive dependency is a new technique. So now first we will go for meaning. What is transitive dependency? Transitive dependency is nothing but in a table, if non-key column, non-key means non-primary key, depends on non-key column. That means a non-primary key column, suppose it will be depends on another non-primary key column, then these column is called as what? Transitive dependency columns. Okay, na? A non-primary key column depends on another non-primary key column in the table. If that kind of columns are there, then those columns are called as what? Transitive dependencies we called. And those type of columns, sir, we need to separate. Separate means another new table create. Okay, that is called a separation. That is the mean of this. Let me come and see. A comma, B comma, C comma, D. These are the four columns. Out of four, A and B are key columns. That means primary key columns. C comma D are non-key columns. That means non-primary key columns. Then D depends on C, but not A and B. So D depends on C. D is a non-primary key. C also non-primary key. If D depends on C, but not A and B, because A and B is what? Key columns. If it is not depend on A and B, it's a depend on only C, then that kind of situation is called transitive. Let me see one example here. Again, I'm taking my next level of table, score table. Score table, student ID, subject ID, both are primary key columns. Here marks, examination name, and total marks. So marks is a dependency column, fully dependency column, depends on student, subject. And now next I have to check what now? Examination name. Examination name, total marks are there. So now examination name also depends on what? Sorry, examination name depends on what? Students and subject. So this is also dependency column. But come to total marks. Total marks is depending on where marks are, examination name are, student or subject are. Marks are? Sure. Not a student and subject. Not examination name. All are means it is what? It's a fully dependency. Total marks, student and subject, not. Keep it side. Either marks column or examination column based, you can take a total marks. So marks column also not depends on total marks. Because of reason, total marks will be depends on examination name. How, sir? For example, in your BTech, MTech, whatever it is, every subject is have 2 examinations. Yes or no? What are those? In your BTech, is there any subject is there you return 2 exams? Internal, external. 2 exams are? Otherwise, somebody saying that theory exam, practical exam. Theory exam 75 marks, practical 25 marks of your subject 1. Then subject 1, total marks how much? 100. That 100 marks, how the people will decide? Based on examination names. How many examinations? 2 examinations. Theory, practical. If theory, okay, 75, practical 25 of a particular subject, then what I want to say, that subject to total marks, how much, sir? Means 75 plus 25 is equals to 100. That is called a total marks. Total marks is different. Obtained marks is different. Obtained means what student is got it. Student getting marks called a obtained marks. Total marks means it's a total examination marks. For example, your BTech first semester, total marks how much? I'm not asking your total marks here. If I'm saying what is your obtained marks means your marks. Total marks means BTech first year, yeah? Oh my God. So your study, whatever you study also, tomorrow your children are asking, suppose you are a BTech, MTech, after marriage your children are asking, children are expected, my mother is a heroine, my father is a hero. Certain level, the children's role models are what? Parents. Every child is saying that my dad is a superhero. They will thinking like that. Because of they believe like that. Of course, day by day, when they growth, what is your daddy? What is your mummy? They can understand. Yes or no? But initially, up to 5th class or 7th class, and nowadays children are very fast. In our generation, we are thinking up to intermediate degree, my dad is superhero. But now, UKG student, my dad, waste fellow. They're saying like that. Okay, so they're asking, guys, it's not a joke. And later we are so much insulting, our children's only insulting to us. They expected my dad is a superhero. My dad can do anything. They will expect it in front of their friends. Okay, na? So they will bring their friends to our home. Hey, come, I will meet my dad. My dad is very intelligent. You can ask any question. My dad will respond. He will be telling like this because his believeness like that. He's a child, a certain age person. He believed everything is my dad and my mother. And they are only supermans. They can do anything. That kind of, they have a believeness. So their friends are coming to home. Ask Ray. Oh, no. You ask your father, now you can ask. So your child is asking, daddy, so and so. So what is the answer for this daddy means? At the time you didn't say, beta, kya bol raha hai? Okay, beta, okay. Go to ask mummy. If the child, mummy, then what are you doing here? You should tell daddy. If you say, dad, my friends are there, don't insult me, tell. Answer no. I don't answer. What happened? We are not responding. Then tomorrow, these guys are, your daddy, superhero, he was insulting in front of their friends. So that's why nowadays, and your future generation people like robots, your children's, I'm telling. Now our generation children's only too much intelligent. What we can say? The 9 months baby can access your mobiles. All of you know. If the baby was come to 1 year, mobile operating will be no. They know how to go YouTube channel, how to play videos, that kind of the what we can say fastness, the generation people. Okay, na? So my child was there. Okay, he was 1.5, second one, not first one. Second one, he was going to be open tab. He will be open tab, and what we can say pattern draw. I was given pattern down 2 to 3 times. I show you, daddy do like this. That 1.5 baby, when open your tab it will go that pattern. Daddy open. So I shock. Yes or no? 1.5 year, the baby. So really I shock. What, 2 to 3 times I show it. So he followed. So that means how much brain that was. Okay, na? And first my son was came. Already you know that. My elder son. He was a rock in mobile operation. He was now 5 years. I don't know some options how to open in my mobile. He will come, Dad, give me. I will give it. Daddy, open. Hello. So that much fast generation people. If they are asking any question to us, if you're not responding, what happened? They will thinking that my dad is a waste fellow. He don't know anything. And you telling that you BTech, MCA. Well, what MCA, BTech, waste fellow? You don't know anything. So they are shouting like this now. What happened? This 30 years, 40 years, what happened? Life, okay, in front of our child, entire life is gone. Outside we are heroes. Outside we will do so many problems we overcome in our life. Big problems we overcome. In our college days we fights with friend circle. These all we did. But finally when came here, 5 year student is asking, 5 years boy was asking, a girl is asking one question, you're not responding now, then what happened? These all are damaged. This 30 to 40 years, whatever you earn, that everything is damaged in front of your child. You know, my elder son is asking sometime, Daddy, what is the spelling of marketing? Suddenly, when we are doing some work, son come, Dad, I have a doubt. What is that? He was asking spellings to me. Spellings. If the marketing spelling also, if I didn't say, what happened? He's asking, what is a lady finger spelling, Daddy? What is that spelling? This spelling. What you say this in Telugu, in English? He was asking. Suddenly, when come and ask when he studied. So if you're not responding now, and of course, some vegetables names we don't know. So many people doesn't know the vegetables names. Yes or no? Suddenly will come, Daddy, what is this? Mummy, go, mummy. We are saying like that. So that's what. That's why some knowledge is required to educate our children. Understand? Na? If you are just now 4 years back, you did your first year, first semester, total marks, how much means you are all are. My MCA first year, actually, we don't have a semesters in first year, entire 1 year, 600 marks, my MCA in 2004. 2004 MCA first year total marks is 600. Second year first semester 480. 480. When I studied 2014, 2014 my MCA. Still now I know how many marks. You people what here? Recently completed, na? What is that? 600? And when I said, you said 600. I think in BTech first year, all are having a common subjects, na? What it is here? Mathematics, physics, chemistry, English. Maths over. Maths, physics, chemistry, English. Next. C language. How many? 5 subjects, 600. Project. Engineering, drawings. So 600. No, na? Labs. So total tell me. 1,000. 1,000. I think it was changing. Maybe as per university, it will change, na? So Jain to Kakinada is different. Hyderabad different. Different, na? Okay. Anyway, so now tell me. So total marks how to depend here? It's a depends on examination name. So I think one more thing, one more example is there. One more example is there. What is this? I don't know present like that. Yes or no? In your 10th class, in Telugu states, I'm asking. North side, how it is 10th class? How many subjects? North Indian. 6, huh? Total marks? 600. 600. 600, huh? Okay. How many examinations are you attending for 6 subjects in 10th class? 6 only? Here, no North Indian people are not there. Maharashtra people not there. 606 subject, best of 5. Okay, okay. So, how many exams are you writing for 6 subjects? 6 examinations. Okay. I think in Telugu states are different now. 6 subjects, but writing 11 exams. Yes or no? Yes or no? Telugu. In Telugu, Telangana, Andhra, 6 subjects, but writing 11 exams. So 11 examinations, total marks is equals to 600. Because one subject are you writing how many exams? 2 exams. Paper 1, paper 2. If, for example, mathematics is there, how you tell mathematics total marks? How you say? Paper 1 and paper 2. Paper 1, paper 2 combination, we are telling total marks. Yes or no? 50-50, 100. In 50-50, 100, how much a student is scored? That is different. That is obtained marks. Total marks is 100. Out of 100, you got it. You obtained 98, 78, 88. That's your marks. But a subject total marks, how much here? 100 marks. But the 100 marks, how the people will decide? The combination of 2 exams. If you have a single exam, single examination, total marks. If you have a 2 examinations, 2 examination, total marks. Understand now? Same as, for example, nowadays we are writing some competitive examinations, civils, some competitive examinations, UPSC, SSC, yes or no? In that also, 2 types of exams are there, even the banking sector also. Yes or no? One is preliminary, one is mains. So preliminary exam is there initially. If who are qualified in this, they will go to mains. And mains also qualified, then what happened? The best of these 2, final, your performance marks will be taken. So preliminary marks, mains marks, finally give it your final marks. Based on that, your priority will get. That's called a rank. First ranker, second ranker, third ranker, whatever it is. So here, preliminary, mains. Here also 2 examinations. These 2 examinations marks and student performance marks, both are calculated. Then they will take a average. What is your grade? Yes or no? So that means here, total marks is a non-primary key column. Examination name also non-primary key column. Then total marks is depends on examination names. Okay. So based on the examinations, your total marks will be decided. A subject total marks, how to decide? That subject is having how many exams? Practical exam, theory exam, internal exam, external exam. Okay, now. So some subjects are having labs also. That is called a practical now. So this 2 combination of exams, that means a student is attending 2 exams, theory attending and practical also attending. So that means are you writing 2 examinations? Then final marks will be decided as a total marks of a subject. Understand now? So like this, here total and mark examination, these 2 are dependencies. And these 2 are called as what now? Non-primary key columns. So that means these 2 are which type of columns? Transitive dependency columns. So transitive means what now? A non-primary key column depends on another non-primary key column, is called as a transitive. Okay, now? So that we find out in this. Okay, 2. Then what I want to do, when you find out the transitive dependencies columns, then these two columns will be separate. The two columns will be separate. One table, score table, student ID, subject ID, marks. I kept as it is my existing table. And in this existing table, one new column is added. What is this? Examination ID. I keep it that. Next, one more table designed, exam table. In this sort, examination ID, examination name, total marks. Examination ID 1. What is workshop? Workshop total marks 200. 2. Mains 70. 3. Practicals 330. So, as per workshop is one exam, mains exams, practical exams. So, every exam, the total marks will be separated here. And in this table, examination ID is called as what? Primary key. This ID, I'm making relation with the score table. That's called a foreign key. So primary key, foreign key. In this two, which is parent, which is child? Primary key is a parent. This is child because it was having what? Foreign keys. So now separating like this. Now in this table, you can see score table. Do you have any transitive dependency columns? Having this? Having this? No. In this, you have any transitive dependency columns? No, because what it was there? Primary key. So that means this is what? Fully dependency table. No transitives. See, whenever it was having primary key, almost when primary key is there means maximum your table will avoiding your problem. Okay, na? That's why in real time, almost every table is going to be created what? Primary keys. Primary key advantage is what now? Any problem can be solved if you have a primary key maximum. Okay. So now this is what now? No transitive dependencies. Okay. And here also no transitive dependencies because of reason your primary key is one of the new column I added. And based on this new column, this remaining data can be get it. Okay. Now, and here this is what relation of this table, two tables. Relation of these two tables. Now here also there is no transitive. This is also what? A fully dependency column. Now these are what? A fully dependency columns. So now there is no transitive dependencies in these two tables. It means these two tables are supporting third normalization technique. Okay, now then next we will see what is the next level of that is called what? Voice code normalization form. Okay, now the next technique. In this technique, what it was say, for a table to be satisfied, a voice code normalization form, it should satisfy again two conditions. Can you observe? Every rule is having two conditions. First condition is previous condition should satisfy. Previous form should be satisfied. What is the previous? First normal, leave it as. Second normal, satisfied. First normal plus no partial dependency. This is two conditions. Third normal, what it was say? Satisfied second normal plus no transitive dependencies. Now, boys code, what it was say? Your table should be third normal plus super key columns. Okay. Now see, every form, the previous form will be related. Yes or no? That should be remember. Link is observed. Okay. So now your boys code. Boys code, what it was say? It should be in the third normal form. That means third normal means no transitive dependency columns. That's okay. Second one, what? Any dependency for A depends on B, for example, then A should be super key. Any dependence, either A depends on B, A should be super key. B depends on A, then B should be super key. Understand now? Here new concept is came. What is the new concept? What is super key? Okay, now? First definition read. First definition read all of you. What is super key? Okay. What it was say? A column. A column means single column, or else combination of columns. That means multiple columns, either single column or combination of columns, which are uniquely identifying a row in a table. So a single column values whatever it was there, that each and every value of a single column should identify a row with a uniqueness. Unique means different. Again, somebody same. Different here. Unique means different. So that is what. So single column. Either what it was saying again, combination of columns. If any two columns combination of data will identify each and every row with the uniqueness. Again, that is also called as a super key columns. Definition understand a little bit? Now practically you can see. Student table is there. In this, student ID, name, branch, mail ID, and registration number. So one by one column, you can check whether super key column or not. First one is called as a student ID column. Student ID column, how many values are there? 1, 2, 3, 4. Now tell me, in this student ID column, whatever the values we have as a row wise, then each and every value of a row is uniquely identified or any duplicates are there? Unique identified. So first row identified with 101. Second row identified with 102. Third row identified with 103. Fourth row identified with 104. So that means how many rows? 4 rows. Each row, how it was identified? Any duplicates or uniques? All rows are uniquely identified. Unique means different numbers through identified. There is no duplicates. Okay, na? So that means now say student ID column is a super key column. Yes or no? Yes, na? Definition satisfied? Yes. Okay. So student ID is one of the super key column. I keep it this. Next come to name column. Name, what is the name? Sai, Jones, Ellen, Sai. But here Sai, first row, last row, these two rows are identified with a different names or same name. Same name. That means this column is comes under super key? No, never. This column is not comes under super key column. I just leave. Next, branch. First row, second row, same branch with the identified. That means this is super key. No, this is not a super key. Next, mail ID. Sai mail ID, sai@gmail.com. Joy, all, me. Now tell me, this is super key. Every user ID is a different, same. Different. Suppose my Gmail ID, your Gmail ID, same. My Facebook ID, your Facebook ID, same. No. So every, okay, user IDs are different. Different means uniques. Okay. So that means this is another super key column. Now, how many super keys as of now? 2. Next come to registration number column. Every student registration number, different, same. So that means, can I say it is also super key? Now tell me, how many super keys in this? 3 super key columns are there. This is the way to identify your super key columns in your table. Okay, that's why this is individually it is. That's why individually super key columns are these 3. Every individual column is uniquely identifying a row in a table is called as super key columns. So STID, mail ID, registration number, super keys. I just keep it. Again, what it was saying, combination of columns. For example, if any combination of columns, still it will be identify each and every row is a uniqueness. Then again, those combination of columns also called as a super key. Now let me see. Student ID, mail ID combination. Check it out. Super key? Yes or no? Yes. Student ID, mail ID, any combination you can see. Any combination you can see. These are called as what? Super key. Next, mail ID, registration number combination. Super key? Yes. These are also different combinations are there. So these are also super key. Next, registration number with the student ID. Super key? Yes. So that means here what it was say, student ID plus mail ID combination also super key columns. Mail ID registration number STID. All are super key. Next, what is the next one? Student ID, mail ID plus registration. 3 columns. Can I say super key? So that means what do you understand? A super key plus super key is equals to again super key. Okay, na? Any 2 super key columns or more than 2 super key columns will become a super key. A super key plus a super key will become super key only. Understand, na? So that is super key definition. And to identify your super key columns in your table. Either individually we can find out, any combination you can find out. Okay, but the individual combination, if it was showing each row with uniqueness, then it is called as a super key columns. Understand now? Next, what is candidate key? Now read. Candidate key, read. This definition, read. Otherwise, both definitions read, no problem. Once read your side. Okay. Candidate key, how to identify means a minimal super key which is uniquely identifying a row in a table is called as a candidate key. So a minimal super key saying. Minimal means what now? For example, in this table, there are 3 levels of super keys are there. One is 3 combination of columns, super key columns. Any 2 combination of columns, super key columns. Every individual columns, super key columns. As per your definition, what? Candidate key, minimal super key column, which are uniquely identifying a row, is called as a candidate key. Now tell me, in these 3 levels, which is minimum? Individual columns. So, super key plus super key, careful observe. Super key plus super key will become a super key. But super key plus super key will not a candidate key. Any 2 super key columns or more than 2 super key columns will become a super key. That we say. But any 2 super key columns will never become a candidate key. So that's why this is not a candidate key. This is not a candidate key because combination. So what is a candidate key? Individual. Every individual super key is also called as a candidate key. Every individual super key, every separating of super key column is also called as a candidate key. But super key plus super key, never candidate key. Understand, na? Same thing, below definition also same. What is saying that? A super key which is subset of another super key is called a candidate key. But the combination of super keys are not a candidate key. Got my point now? The combination of super keys are not a candidate key. But the subset of another super key is called as a candidate key. Subset. Subset means what now? This is 3 level. This is 2 level. This is 1. Can I say 2 is a subset of 3? Yes or no? This is subset. 1 is subset of 2. This is called a subset. What is your subset? Minimal individual. So the minimal subset of another super key, subset of another super key. Finally, whatever the subset will be getting here, this is called a candidate key. Why? Because any combination of 2 super key columns are not a candidate key. It means that what it was come? Individual subset. The subset of every individual super key, the subset of every individual super key is called a candidate key. So, but combination of super keys are not a candidate key. So that's why we should take a individual only. We should not take a combination, because combination will not be candidate key. So now understand the definition. Now let me come here. Candidate keys. What is the candidate keys? Student ID, mail ID, registration numbers. So finally, this is super keys, individuals. Any 2 combinations super keys, any 3 combinations super keys, these all are super keys examples. But whereas candidate key, what now? Individual super keys are called as a candidate key, but not a combinations. That is called a candidate key. So candidate key examples are STID, mail ID, office, registration number. These are 3 individual. These are the individually we call it candidate keys. Okay, now super key, candidate key. Okay, now come back. Now this is your table. Composite primary key. What is the mean by composite primary key? Means what now? When we apply primary key on combination of columns, we call it a composite. But tell me, composite primary key, how the data can be verified? Individual columns are verified. Combination of columns are verified. Combination of columns are verified. Yes or no? Are you remember now? So India versus Australia, India versus South Africa, India versus Pakistan. Now tell me, is there any repetition of matches there? No. These 3 matches are unique matches or repetition matches are? Unique matches. India, Australia, 1 unique match. India, South Africa, 1 unique match. India, Pakistan, 1 unique match. So 3 are different matches. But here common is what? India. That means India is a common, means I can't say these 3 matches are repetition matches. I can't say. These 3 are different because different combinations they are playing. Understand now? So that means India. Sorry, India, they are not duplicate now means no, that is not a duplicate. Because here not individually check. It was checking combination. That is called a composite primary key. Composite unique key. Okay now? So now we are observed. Student ID subject. These 2 are composite primary keys in my college enrollment table. Professor is a non-primary key column. Then you can see in the professor depends on what? Subject. That's common. Professor depends on not student. Professor depends on subject. Okay. But in this two, you can see professor is a super key or not. Check it out. Not super key. Because Professor Java. It's not a super key. But subject you can see super key. Yes or no? Every combination is a unique. Now you can see 101 Java is a one unique combination. 101 C++ is a one unique combination. 102 Java, unique combination. 103 Oracle, unique combination. 104 Java, unique combination. Is there any duplicate is there? No duplicates. So that means your subject is what? It comes under super key. Professor is what? It comes under non-super key. But as per the rule is what now? If A depends on B, then which should be super key? A should be super key. But here A is who? Professor. B is who? Subject. Professor depends on subject. That means A depends on B. That means in this two column, which column I want to make as super key? Professor I want to make as super key. But professor is a non-super key in this. So this table is not satisfied. Voice code. Then what I want to do? I want to reverse. How I can do? Now we can see. Professor table I'm taking now. Separate table. Composite. Professor ID. Professor subject. Okay now? Now in this, subject is called as a non-a primary key. And this is maybe there is a chances it is having what now? Non-super key. Because of reason, on this subject column, can I insert a duplicate? Hey, see carefully. Can I insert duplicate data in this? Yes, we can. Because is there any primary key on this table, on this column? No, that means it is a non-primary key. Non-primary key can accept duplicates now? Accepted or not? So this is accepted. That means this is a not a super key. Professor is what now? Composite primary key. In this composite primary key, professor ID, professor, is it possible? Can I insert a duplicate? Huh? No. Because suppose you can see, can I give it like this? To Professor Java. Can I give it? Yes. Because one Java, two Professor Java, different. Now, can I give it to Professor Java? Can I give it a allowed? It is never allowed. Why, sir? Because duplicate combination, not allowed. Okay, na? But can I say here? Can I say here to Professor Java, subject is Java? Can I? Yes or no? Yes. Yes, it's possible. It is allowed. But already Java is there now. But still allowed. Allowed means this is a super key or not super key? Non-super key. Because super key means what now? Every row should be uniquely identified. But here, subject here, first row Java, third row Java. What is this? Unique or duplicate? So it is not a super key. But this is Professor. Professor is super key. Yes, because each and every combination is a unique. Okay, some little bit confusion is there. But okay, no problem. When you, this idea will be there now. When you enter into companies, you can understand. Okay, the main work, real-time work, when you see, automatically understand. But initially, as a fresher, little bit confusions are there. Okay, na? So now this is what now. I just change here. After just swipe here, what it was happen? So now professor depends on subject. But now professor is a super key column. Subject is a non-super key column. So now this is satisfied of voice code normalization form. Okay, na? So now, and now this relation satisfied voice code normal form. Okay. So up to these four are important for you. So that means first normal, very easy. Everyone just four conditions, check it out. Second normal, main focus on partial dependency. Third normal, transitive, and BCNF super key. These are the three different concepts. If these three concepts, definitions, meanings understand, it is also very easy. Otherwise, so many people are confusing in these three only. Okay, na? So these are the 4. It's a mandatory techniques for your table verification. That means your designing level, your table should be verified like this, checking like this. But what I said, 4 and 5, these are what? Optional size set. It's not, so many people are avoided, not using, but still, why, sir, it is not used? Why it is called as a optional? Now, let you see this example. For a table to satisfy 4th normal form, it should be satisfied 2 conditions. First, your table should be Boy's code normal form. First thing. Second one, this is important, observe. A table does not contain or does not have it more than one independent multi-valued column. Attribute means column. So in this 4th normalization form, what it was saying here, your table, in your table, should not contain more than one independent multi-valued column. That means by the statement, what do you understand? Suppose if my table is having a single independent multi-valued column is there in the table, is it problem or not a problem? As per definition, problem or not a problem? Not a problem. But in my table, I have more than one independent multi-value columns are there. Then it is a problem? Then it is a problem? Yes. Then that was not satisfied for enough. So now what is multi-value dependency, sir? Here observe. In a table, one column, see definition very important to understand first of all. One column, same value, match with or joins with multiple values of another column. So a column, same value, will joining with multiple values of another column. Then it is called as a multi-valued dependency. Got it up? Now we can see example, observe. In college enrollment table, I have a student ID, course, hobbies. Course is different, hobby is different. Can you tell me course and hobby, is there any dependencies? No, it's no meaning of those two because those two are independent columns. So now, careful observe. This is what? Student ID, a column. Same value? Same value? Yes or no? Now join with one Oracle, one Java, one C#. That means a column, same value, will joins with multiple values of another column. Satisfied? That means this is called as what now? Multi-valued column. Understand now? Right. Like this. Another one is also there now. One cricket, one reading, one hockey. Again, same, a column, same value, multiple values are joined. That means, can I say it is also multi-valued column? Now tell me, in this table, how many multi-valued columns? 2 columns. Course, hobby. But 4th normalization, what it was tell us? A table should not contain more than one independent multi-valued columns. But my table is having a, yes or no? This is one multi-valued independent column. This is another multi-valued independent columns. That means how many multi-valued independent columns? 2. But as per rule, we should have only 1. But yet 2 is there. So this is what the table. Now what I want to do? I want to decompose, split. Now I'm splitting. One table I created hobby. One table I created course opted table. And now we can see hobbies table. 4 enough. Satisfied? Huh? Yes or no? How many multi-valued columns? 1. Satisfied. Course? Satisfied? Huh? So now these two tables are called as, comes under what? 4 enough tables. 4 enough tables. Got it? Huh? So 4 enough this is. 5 enough what it was say here, observe. If a table having multi-valued columns and also that table cannot decompose. Decompose means splitting, dividing. Don't decompose into multiple tables is called as a fifth normalization. If you read this definition, it's quite opposite of 4 enough. 4 enough, what it was telling us in your table, if you have a multi-valued independent columns, then you need to separate. That is called a 4 enough. 5 enough, what it was say, don't separate. Keep as is. That's called a fifth. So that means here, observe. If you're separating 4 enough, if you're not separating and keeping as it is, this is called as what? 5 enough. Got it now? So when you separate 4, not separate 5. So that means here, what is the chance to the programmer or user or designer? What is the advantage of designer? Either your wish. If you making separate, 4 enough satisfied. I got my result. If I'm not making separate, 5 enough got it. So these two, any one you satisfying here. That's why 4 enough, 5 enough is a optional. Either you do, you didn't do. That means if you do it, nothing problem. If you're not do it, nothing problem. If you keep as is, it is a 5 enough. If you split, it is a 4 enough. So do it or not do it, it depends on database designer as per their requirement basis. Okay, na? So that's why here these two not a mandatory techniques. It's a choice of users, okay, or designers. They will be, they will not be. Okay, that's there is their wish. Okay, na? Depend on their requirement, they can. Otherwise, they leave it. So these are what now, guys, here. The normalization technique. Okay, na? And this completely, who will use here? Database designers will follow this concept. And you also, if you have a little bit idea, then it will be somewhat better for your Java projects whenever you want to developing some Java projects, .NET projects at the time. If you have a little bit normalization concepts, ideas, then designing level, it was very easy to you. Okay, this entire document, I will share to into Google Class. So up to here, your SQL part is completed. Okay, right. And the next is second part of Oracle. This is called as what now? What is this? PLSQL. Okay, no? So PLSQL. Okay. So why, sir? In PLSQL also some concepts are there. Don't hurry, worry. Huh? So PLSQL. Okay. Why the people was introduced here after SQL language? Okay, now. And what is the differences between SQL and PLSQL? Okay. So if any new technology was introducing in the market or a new futures are introducing in the market in a particular technology, it means what? One new technology came, one new future came, one new language came. It means what? Existing language or existing technology will have some drawbacks. Yes or no? So we all of you know COBOL Pascal after your application development started from C. From C onwards, application developments are started. But which kind of applications I can develop? Stand alone. But in the C, there are some drawbacks are there. What is the drawback of C? It's not a object-oriented program. Okay, na? It was supporting pointers so that security problems are come out. Next one is what now? It is not a atomic memory management. It's not a automatic memory. That means garbage collector. Garbage collector. There is no garbage collector in C. Next, it doesn't develop